Alright guys, I'm going to go over final exam for semester review number 2. Just so you know, in the video I am going to go rather quick. I'm going to try to fit in as many examples as I can, but know that it is a video and you can pause if you're not quite through all the steps that I'm doing. You can rewind if you need to rehear them. So let's get started on number 1. So the first thing I notice is that I have an 8 on the outside of my parentheses here, and I'm going to go ahead and distribute that in. So I get 5a minus 9 equals 32a plus 40 plus 5. Don't want to forget that guy there. I'm going to go ahead and combine like terms on the right side of my equation, and I get 32a plus 45. Now I want to get the variables to one side and the constants to the other side. So I'm going to subtract this 32a to this side, and I'm going to get negative 27a, and I'm going to add 9 to both sides, and I'm going to get 54. So if I'm solving for a, I'm going to divide by negative 27, and I get a equals negative 2. Now going over to question number 2, I actually have distribution twice, so I have to distribute this negative 6. So I have negative 12n plus 42, and on this other side I have negative 48 minus 18n. And again, just like I did on number 1, I'm going to move my variables to one side, and I get 6n, and I subtract that 42 to the other side, and I'm going to get negative 90. If I divide both sides by 6, I get n equals negative 90 over 6. Now, I don't know that off the top of my head, so let's do some quick chicken scratch. 6 goes into 9 one time. 6 goes into 30 5 times. So n equals negative 15. Probably should have known that one off the top of my head, but I didn't. Alright, scrolling down to 3 and 4. I have to find the inverse, and steps to know when you find your inverse is to 1, switch x and y, and 2, solve for y. So in this case, my n is my x and my f of n is my y. So I'm just going to rewrite it using x's and y's just because it's easier for me that way. And I'm going to switch my x and y like step 1 says. So I have x equals 2y minus 6. And step 2 is to actually solve for y now. So if I add 6 to both sides, I have x plus 6 equals 2y. Divide both sides by 2. So y, or the inverse I should say, is 1/2 x. That 1 comes from here and the 2 comes from the denominator. Plus, I have 6 divided by 2, which is 3. So my inverse in this case would be y equals 1/2 x plus 3, and that's my inverse. For question number 4, it says to solve each equation, and I notice that this is absolute value. That's what these right here are. So when we do absolute value, we have to split this into 2 equations. So I'm going to have 4 plus 4x equals 4, and 4 plus 4x equals negative 4. So if I'm solving, I'm going to subtract 4 to both sides, and I get 4x equals 0, divide by 4, and I get x equals 0. For my second equation, if I subtract 4, I get 4x equals negative 8, divide by 4, and I get x equals negative 2. So my two values that I get for this absolute value equation is x equals 0 and x equals -2. And just to point out, the reason we have 2 is because we set it equal to the positive of this side, and we set it equal to the negative of that side. Alright, with number 5 and 6, it actually tells us what to do. It says solve by taking the square roots. So if we recall, taking the square roots means that we need our squared expression by itself. So right now I have a 9x squared. That 9 is preventing that x squared from being by itself. So I'm going to divide by 9. So I get x squared equals -9. Right? -81 divided by 9 is -9. Now, since my x squared is by itself, I can take the square root, and I'm going to get x equals plus or minus. Now, if you don't remember, a negative inside of a radical, well, this is -1 times radical 9. And most of us know that the square root of 9 is 3. So the only thing we're not kind of taking into account here, if we just left our answer as plus or minus 3, is this negative in there. So when we have a negative inside of a radical, we actually take out the I, because I equals the square root of -1. So my final answer is x equals plus or minus 3i. For number 6, we're going to go ahead and subtract the 5 because we're trying to isolate the squared term. And I get 8x squared equals 672. So I need to divide by 8 to get the x squared by itself. So x squared equals 672. Well, let's see. 8 goes into 67 8 times with a remainder of 3. So 8 goes into 32 4 times. And if I take the square root, now that it's isolated, I have x equals plus or minus, and let's see if we can break down 84. So 84 is actually 4 times 21. 21 is 3 times 7, and 4 is 2 times 2. So we have 2 times 2 times 7 times 3, which is 84, and the 2's are what is squared inside, so I can take a 2 out, and left inside is that 7 and 3, and 7 and 3 is 21. So my answer here in simplified form is x equals plus or minus 2 radical 21. And moving on to question 7 and 8. So both of them say simplify. We have to decide what we have to do to simplify. And if I look at question 7, this one actually has a subtraction sign here. So that means I'm going to subtract these. Don't make an error by foiling these. This isn't multiplication, it's subtraction, right? So I'm going to distribute that. I did nothing with my front parentheses. I have a -3 minus I because I distributed it to both of these. If I combine like terms, I have 4 minus 3 is 1, and a positive I and a negative I, they actually cancel each other out, right? So my answer to this one is 1. For number 8, there is no addition or subtraction here. There's actually multiplication, right? So I'm going to go ahead and FOIL this, or distribute it. 42 minus 48i and -21i plus 24i. Oh, I squared, I'm sorry. See, there's an I times an I, that gives you an I squared. So if I combine like terms, I can combine these two. I would get 42 minus 69i plus 24i squared. Now, if this was a multiple choice test, I would probably put a trick answer that looks just like this. However, this is not simplified. we need to replace this I squared. Remember, I squared equals -1. So I need to replace that. I would have 42 minus 69I plus 24 times a -1. So that's actually a -24. So I have 42 minus 24 that I can combine. When I do this, I get 18 minus 69I. Now, do we write it as 18 minus 69I, or do we put the variable first and the constant last? Now, typically, especially when we talk about lines, even polynomials, we talk about how you have to put your variable first, or highest degree first, and then all the way down to your constant. However, we're talking about imaginary numbers, we're talking about complex numbers, so we need to write it in the a plus bi form. So this is actually my final answer. Okay, now let's look at 9 and 10. So both say factor. First thing I always say to do when we factor is look for your greatest common factor. I don't see anything that these three have in common. So I do notice that this is a trinomial. So I'm going to break my trinomial up and say what multiplies to v squared is v and v, and what multiplies to 14 is 2 and 7. And in order to get that middle term, I would multiply these, and I would get 2v and 7v, and how is that going to get me 9? Well, if I add both of them, I will get 9. When we check our factoring, I always say to check our signs. Does positive 2 times positive 7 actually multiply to give me this positive 14? It does. And since we're solving, we now set each of these equal to 0. Subtract 2, v equals -2. Subtract 7, v equals -7. Okay, for number 10, we're going to start the same way. What do they have in common? So 6x squared minus 8x plus 2, they all have a 2 in common. So I'm going to go ahead and factor out that 2, and I would get 3x squared minus 4x plus 1 equals 0. And if we were just factoring, we wouldn't divide over that 2. Since we're solving, I could divide that 2 to the other side. But I'm just going to go ahead and go straight to my factoring. Since it's a trinomial, what multiplies to 3x squared is 3x and x. What multiplies to 1 is 1 and 1. Now, how do I get that middle term? I have a 1x and I have a 3x, and the only way I'm going to get a -4 is if both of these are negative. So I have a negative and a negative, and again, check your signs, do a -1 and a -1 still multiply to this end? It does. So if I set each of these factors equal to 0, I would have this one here, 2 equals 0. Well, no, there's no x in there to solve for. How about 3x minus 1 equals 0 and x minus 1 equals 0? And I solve these. Add 1 to both sides. 3x equals 1. Divide by 3. And x equals 1/3. Over here, I add 1, and I get x equals 1. So my two solutions are x equals 1/3 and x equals 1. If you want to check your work, go ahead and substitute them in here for x and see, do you get 0 when you substitute these in? I'm going to go ahead and end the video here so that I can pick up the next one starting with number 11.